Welcome to this webinar as part of the Biometer Focus Month with Haag-Streit. My name is Thomas Beutler. I am the product manager for anterior chamber analysis, biometry, and IOL calculation with Haag-Streit. It's my pleasure to join you here and to introduce this webinar for you. I would like to share some housekeeping rules to start with. So the webinar itself is going to be recorded, and we're going to use the Q&A section of Zoom to post questions, which are going to be answered at the end of the webinar. Now it's my special pleasure to introduce you Abdo Jamal. He has more than 20 years of experience in the field of medical devices, not only ophthalmology. His basic training is IT engineer. He has joined Haag-Streit 8 years ago as an area sales manager for the areas of the Middle East, Africa, and Latin America. And currently, he's now our sales specialist for biometry, focusing on the Lenstar and the EyeStar as well. And it's my special pleasure to introduce him to you for his webinar, Lenstar, Data Validation and Toric Planning. So I'd like to hand over, Abdo. It's your screen. Thank you.
Okay, thank you, Thomas. Let me first share my screen and make sure everything is working well. Okay. Can you see my screen, Thomas?
Perfect. It's all set.
Okay. So thank you, Thomas, for the nice introduction. Hello, everybody from my side, and welcome to the second webinar of Biometry Focus Month. This webinar will be around 25 minutes long and available time, as Thomas mentioned, for question and answers. We have more webinars, as you saw, and you can see all this information in our webpage. So today our talk is about Lenstar, a device that proved it produces high accurate measurement data that helps surgeons to achieve best outcomes for their patient. We will start with an overview about Lenstar measurements, tips for good measurements as well. I will then demonstrate how to review and validate correct certain scans. Further, an overview of IOL calculation methods available with the Lenstar, with focus on how to handle toric cases using EyeSuite Toric Planner. I will toggle between the presentation and EyeSuite software, showing cases to make things easier for you to understand. Let's start. The Lenstar, as you know, is an optical biometer that transmits light beam across the eyeball. It analyzes the reflected light to form a signal profile. The Lenstar uses each eye scan signal to measure central corneal thickness, anterior chamber depth, lens thickness, retinal thickness, and axial length. An eye image is captured at the same time while we're measuring the axial length. This eye image is used to measure the gaze, wide to wide, pupil diameter, and the eccentricity. I would like here to highlight the Lenstar case accuracy. Lenstar uses 32 points in dual zone pattern, 16 points on the 1.65 mm and 16 points on the 2.3 mm zones. Dr. Hill published a study in 2011. This study proved that Lenstar cases are equal to the gold standard, the Jamal manual keratometer. Cases are very important parameter in any IOL calculation. Lenstar scans on the visual axis. Please remember that with one scan, we can get all these measurements. We always recommend to do 5 scans for each eye. I would also draw your attention that I will be using EyeSuite i9.10 for demonstration. To check what EyeSuite version you have, you can click on the question mark on your EyeSuite and then click About EyeSuite, and here you find what version you are using. If you're not using the latest version and you would like to update your software, please contact our local distributors. You will find our authorized distributors on our webpage. So, as mentioned earlier, Lenstar helps surgeons achieve the best outcomes for their patients. But in order to produce highly accurate measurements, we should pay attention to few things. First, I think we have to consider that the patient is nervous when he walks in the clinic. He or she doesn't know what he will experience in front of the device. So explaining the test will be a relief for them. Ensure the patient is in a comfortable posture in front of the device, correctly positioned and looking to the fixation. Encourage blinking after each flashlight for wide eye open and optimum tear film. Treat dry eye if possible and ensure eye drops are used well in advance, because using this before the test may affect the K readings while measuring the case. Avoid performing applanation tonometry, and for hard and soft contact lens patient, please ask them to remove them for at least 2 weeks before the examination. Now, after we've done with the scan, it's always good to have a closer look on the results. If nothing you see is abnormal, we can continue without reviewing the results. But it's very important if we have dense cataract result, high standard deviation, significant difference between the two eyes, cautions, pre-known eye conditions like pseudophakic, ICL, whatever. I would say here it's a must to review and validate the data with the Lenstar. We should also look at the most important measurement, like the axial length and K reading, and validate them according to the accepted standard deviation. Axial length should have a standard deviation less than 0.1 millimeter, and Ks should have a standard deviation of less than a quarter of diopter. We also need to be sure the axis has standard deviation of less than 3.5 degrees, only if the patient is a toric candidate. Now, also, it's good to mention that EyeSuite software has two cautions symbol. They are used to bring our attention to questionable measurement results. This doesn't mean that you have a bad measurement. It's just like to draw our attention to this. I will switch now to EyeSuite to demonstrate how to validate and correct the data. Let's start with a dense cataract mode, where Lenstar will measure all the eye biometry, but not the AL or the axial length. Our advice here is to continue measuring and complete the 5 measurements. The DCM kicks in after the 3rd measurement, and the software will actually use an algorithm to create a composite axial length value. So I will show now 2 cases for dense cataract where the dense cataract mode could find an axial length measurement. First one, we see here 1 axial length measurement with no standard deviation. And this is because we could find this axial length results once. If we click on any number here, we find the profile image. And we see that the axial or the retinal reflection is spread out. In my opinion, in such case, it's better to do an ultrasound to confirm if this reading is correct or not. I would recommend an immersion ultrasound, not a contact, but contact is also good, keeping in mind that the contact will give you a shorter axial length than what you get here. The other case is also a dense cataract mode, but here we see the result, the retinal peak is uniform. And here we are confident that this is a retinal signal, and we can use the axial length in our IOL calculation. The third case that we will see here, it's a standard deviation higher than the accepted range. If you can look here, we have, sorry, let me just calculate. Yes, we have two yellow triangle next to the lens thickness and central corneal thickness. What we have to do here, we have two options to correct this. One of the options, if we use the zoom button and zoom in to the lens thickness and change the gate from here to the last detected peak. And then if you see, we can remove the caution and we have a good measurement. We can do the same with the central corneal thickness using the same zoom in, and we adjust the gate and the standard deviation is okay. Another way to do this, which I prefer personally, is to remove the outlier or exclude the outlier. Here, if we see, we can arrange the measurement ascending or descending. And if we look at this measurement, we have 3.454 out of the range. Double click over this, it's excluded, and we have a good standard deviation. We can do the same with the central corneal thickness, and if we remove the outlier, now we have good measurements. If we have a known pathology, or we know what happened in the eye, it's easier. But also, if we don't know, we can modify or correct this afterward. If we look here, I think this was a phakic lens when the user measured the eye, and we got such results. If we click and we look, it's clearly there is a IOL implanted here, and it's a non-phakic eye. What we can do is we tell the software that there is an IOL, please correct it, clicking OK. The software will manage to read this eye as a pseudophakic and will detect the lens or the IOL thickness. An interesting case for me is this ICL example. I see here a case. Sorry, I just need to recalculate where the software calculate the case, and then because I adjusted this earlier. Sorry. So here I have cautions. If I check, I have some cautions on the anterior chamber depth and the lens thickness. If I use the same method that I demonstrated earlier, I can move this gate a little bit here. Then I cleared the caution on the lens thickness, and I also can adjust this here, and then everything is fine. But if I compare the two eyes, I see the anterior chamber on the right eye is 2.36 and 3.21 in the left eye. There is also a difference in lens thickness in both eyes. It's good then to look at the right eye. And looking at the right eye, I see two more peaks in front of the lens. If I zoom in, this is clear that there is an ICL implanted in front of the crystalline lens. So to adjust this, I bring it back, and now I compare both again. Still, there is a difference between both, but the difference is now less than before. I would like to double check once again, knowing that the right eye has an ICL. I zoom in, and here it might be an ICL2. Of course, the doctors find this through the slit lamp, but for me, as validating this data, I can see here that there is another peak, and the lens, anterior side of the lens should be here. If I said, okay, now I compare the result are more comparable. So anterior chamber are close to each other, almost equal, and the same for lens thickness. So here, I think we have a better result than before. Sometimes we can accept the reading after checking. Here I see there is a shallow anterior chamber depth. Looking at the axial length, this is a short eye. This might be true, so I accept this caution while after reviewing the result. The last case I want to show here is the K reading. I can also review the K reading and see what happened during the measurement. Here I have more than quarter diopter standard deviation, which tells me that something should be checked. If I click here and I look at this, there's a question, there is a caution here, and I look at the picture, they are not that well. I can exclude this measurement, and then I think things are a little bit better, but still I have a high standard deviation. I look at each, and if you see here, the dots are not well defined. The same in all scans. I would say that there is a tear film issue or dry eye condition in this eye. It's recommended to treat this before retesting or remeasuring this eye and plan for IOL calculation. So this is in brief how we review and validate our measurements. Let's go back to the presentation and talk now about the IOL calculation methods available on the Lenstar. EyeSuite utilized the most modern calculation available in the market, especially for spherical IOLs and post-laser vision corrected eyes. For spherical or single vision correction, we have several formula to use, and it's always the surgeon choice to use any of them or to compare between them. I mark the Hill RBF in red because this is an exclusive method for EyeSuite. You don't have this, you don't find this method or formula in any other device. Now, with EyeSuite, we have the latest post-refractive IOL calculations as well. And here we have to differentiate between patient with history, where I mean history where they have pre and post refractive surgery data, and patient without history. Different IOL calculation sets is used accordingly. For toric cases, EyeSuite provides state-of-the-art toric IOL calculation. Before we dive into Lenstar Toric Suite, please be careful when selecting toric patient. We should be very careful with lens tilt, dry eye or excess tears, corneal opacity or any other corneal pathology, previous corneal surgeries. More investigations should be considered before taking toric implantation decision for such cases. Now, to properly plan a toric IOL, you need topographer, surgical induced astigmatism value, incision location, and incision size. Lenstar provides a T-cone or topography cone, which is a cost-effective add-on option for users who don't have topographer. Having keratometry and topography is essential for toric planner. Together, they allows us to validate the steep meridian at a glance. They are also reduce the need of multiple testing or multiple devices. The idea here is we are looking for regular butterfly shape astigmatism, like the case here. We are looking for this shape or this shape. If we have asymmetric or irregular corneal shape, this patient is not a toric candidate. Now, it's fundamental for toric planner also to have the surgical induced astigmatism, incision size, and incision location. These data should be entered to EyeSuite Incision Manager so that software can optimize your toric plan. There are few online calculators to calculate your surgical induced astigmatism. And this is a unique number or value for each surgeon, depending on the surgery technique that he's using. Incision size and locations are known, but also we can use a range for incision location. Then the software will optimize the best location for the best outcome. I will switch back to EyeSuite again and talk about the toric planning. So let's take a regular astigmatism case in the beginning. If we look here, we have one diopter of astigmatism in both eye, and here the standard deviation is in the range. So this could be a candidate for toric calculation or toric implantation. But when we look at the topography, we see that this is not symmetrical regular topography. So we have to exclude this patient from any toric implantation. A regular astigmatism case, here, a patient with 2.25 diopter astigmatism in both eye, and before we take any decision, we have to look at the topography. We have here a symmetrical butterfly shape, regular topography. Then in this case, we proceed with IOL calculation and we check what options do we have. I have to change to toric, and then we have two options, one with Barrett using the Barrett, the other with Abulafia Koch. And here they suggest this plan. If the doctor or the surgeon is not happy with the incision or with any of the suggestions, we can click on this small green button and open the toric planner where we can do few changes. If the doctor is not happy with this incision location, we can move it anywhere where the doctor feels it's comfortable for him. And here we can check the anticipated residual astigmatism. This, in my opinion, is a good plan if the doctor is happy with this. What we can do also here, if we want to change the scale, minimize it, or make it bigger, to find the best place where the doctor wants to have his incision, it's also possible. A good thing here also, we have intersection between the red line and the black line, where the best outcome is optimized. Here you see we have zero residual astigmatism. If we change to here, accordingly, the incision location is changed, the same like here and the same like here. One last thing to add here, we need also to have a landmark. So if this blood vessel is well recognized, or this one is well recognized for the surgeon, we can add an angle here and click on this. And then the surgeon knows the angle of this blood vessel. It's at 175.5 degrees. When the surgeon goes to the OR, he can mark this at 175 degrees and then accordingly does his other plan. I also want to mention here that you can also add the topography on top of the image, so you can easily validate that the toric axis is on the steep axis. One interesting case I want to show you here is about when you have a low astigmatism. Like here we have 0.75 diopter of astigmatism. And usually most of the IOL or the toric lenses start from 1 diopter correction. So let's go and do the calculation. And here, if you see, with Abulafia-Koch, the correction, the suggested is 1 diopter, whereas the Barrett doesn't, or there is no model found. This is because the low astigmatism with this patient that the patient has. So what could be a solution to make sure that our plan or the suggested plan is correct? I would do here, add for this lens, a non-toric sorry, 1 second. I will add here a non-toric IOL, and I will call it non-toric and say okay. And now we will have a plan from Barrett as well. Barrett doesn't recommend changing the axe or overcorrection. Meanwhile, Abulafia-Koch doesn't mind doing this. If we want to compare here, if you can see, with 1 diopter, the residual astigmatism will be 0.3 at 153. It's, I think, exactly what is expected here. I will finally talk a little bit about changing the overcorrection and changing the axis. If we decide to overcorrect and flip the astigmatism axis, the patient might need time to adapt to this change, because Usually, if we have with the rule astigmatism, this is the image that is produced with the astigmatism against the rule, I mean, flipping the axis with 90 degree. This could be. So the brain needs time to adapt from this image to this image. Since the overcorrection is usually minor, I don't think it will be a big issue here. But it's always the surgeon decision to do this or not. I want you to take home message that the Lenstar produces highly accurate measurements that help surgeons achieve the best outcome for their patients, utilize the most modern calculation for spherical and post-laser vision corrected patient. It also provides the advanced surgical planning for toric planning. There are no competing devices that have been proven to produce better outcome than the Lenstar. You might find devices that produce similar outcomes, but so far we didn't see a device that performed better when it comes to outcome than the Lenstar. And finally, the Hill RBF is an exclusive formula to EyeSuite. Before we move into questions and answers, I just wanted to mention that if by any chance your question was missed or you have follow-up question, please feel free to email me and I will be happy to reply later on. Thank you for sparing time from your busy schedule, and I hope this was a benefit for you. Thank you.
Yes, thank you very much, Abdo, for your brilliant talk. And we can now move on to the Q&A section. We actually got quite some questions here. I'm going to read them out to you, and then you can reply on them. The first question was, what is your advice for calculating IOLs with RK, radial keratotomy patients? What would be your advice for this particular case?
I'm always conservative when replying such questions because I'm not a surgeon and I'm not in a position to recommend, and I believe most of the recent calculators are good. It's the doctor choice.
I mean, one thing I might add here is EyeSuite IOL currently supports the Barrett 2K for IOL calculations after RK. So there we have this possibility which is built into EyeSuite. And additionally, there are also methods like the ASCRS calculator online that then supports, apart from the Barrett 2K, also other methods like the double K methods or topography-based methods.
Thank you, Thomas.
Then the next question, which was there, was what will be the lens tilt that you should consider if implanting a toric IOL?
To be honest, I didn't see a study that shows like a solid data about this issue, but we consider like anything up to 5 degrees is safe. 5 to 7, we consider it as a borderline, and above 7, it's critical. Again, this is the information that I got from my discussions with doctors that I'm sharing with you. But again, I'm not in a position to say where is the cut line. I don't know if, Thomas, you have anything to add here as well.
Well, I can actually support this 100%. Really, the physiological lens tilt is around 2 to 5 degrees, as you mentioned, and it's really up to the surgeon to decide how far he or she might want to go, when to stop implanting premium IOLs. For sure, the bigger the lens tilt is, the more asymmetric imaging you have there. So you add coma basically to the refractive outcome of the patient, and then it's really up to the surgeon's choice. Very similar to also this first question, it's also the surgeon's choice to say which formula he likes the most to then get a perfect result. Okay, thank you very much, Abdo. Then we move on to the next question. In post-refractive cases, does the EyeStar use as posterior sin K values in the Barrett 2K when doing IOL calculations?
You can use the posterior case, but the Lenstar doesn't measure them. So if you have any other topographer that measure the posterior cornea, you can take these measurements or the thin case of the posterior cornea and add them to the Lenstar and use these data. Let me show you where you can add these. Here you have an area to add the posterior corneal parameters.
This basically also answers the second question, which came, what is the difference between the Barrett 2K with the Lenstar and the EyeStar? I mean, it's pretty simple. The EyeStar measures the posterior K readings, the Lenstar not. So with the EyeStar, you already have this information available automatically. Then next question, for ICLs, we can use the calipers to check the vault as well if we move the two calipers to the ICL posterior lens position.
Yes, we can use the calipers to measure the ICL thickness, if I understood the question correctly.
Mm-hmm. I would add a little more details. I mean, the calipers, they are there, and it might be very tempting to use them for vault measurements, but they are calibrated to the physiology. So it means that behind every caliper, there's also an indices of refraction, and therefore the optical path length isn't transferred to a physical path length. So it's tempting to use them, but the result might not be optimum. It is actually planned to have a specific measurement feature like this for the EyeStar in the near future.
Okay.
And it might also be difficult to see all the peaks with the Lenstar, because we all know that IOLs certainly don't spread the light. So if the lens is a little bit tilted, we might not see all the peaks, and then it might be difficult to judge, is this the anterior surface of the ICL, is this the posterior surface? So really just if all the peaks are there, but even then, the tool is not meant for this.
Yeah, exactly. I do agree with you, Thomas, that the tool doesn't meant to do this, but we can use it for estimation, not for accurate measurements.
Then another question is, how does dilation affect the Lenstar readings?
Actually, I don't know if it affects the reading or the measurements themselves, but dilation, I think it helps sometimes with dense cataract because you have a better window for light to penetrate.
Okay, then the use of topography feature, is there an external attachment needed? Can it be attached 24/7 for AL measurements taken with or without the attachment?
The T-cone is an attachment. You don't need anything than the T-cone itself to mount it on the Lenstar, and you can use the Lenstar the same way with or without the T-cone. So you can do all the measurement with the T-cone attached to the Lenstar. The only measurement that you miss is the pupil diameter or the pupil image, which won't affect any of the IOL calculation.
Okay. Then another question, you talked about validation criteria. Are there any references which could be downloaded for the surgeons?
We have, I think, a validation sheet in different languages. I think it's on our webpage. If not, I can send it to anybody who wants it. Just email me and I will send you these standard deviation recommendation or accepted standard deviations.
Perfect. Good. I guess we are just about to reach the end of the webinar. So Abdo, thank you very much for your kind introduction and your perfect presentation. I would like to actually promote also our future webinars. So just quickly take over the screen here. We have a complete series of webinars in this November, and the next one is just going to be tomorrow. It's going to be Warren Hill talking about how topography and vision simulation may improve your refractive outcomes and patient satisfaction. That's going to be held at 5 p.m. Central European time. So if you want to join us there, be there. We have additional webinars with more speakers, and visit our webpage, scan the QR code for more details. All the webinars are recorded, as mentioned in the beginning. They're going to be available on our YouTube channel and also on the webpage of Haag-Streit. So you can always go there and have a look at them. And as Abdo also mentioned, if you need more information, you can email him directly on the address mentioned in his presentation. So thank you very much and have a wonderful afternoon. Thank you very much, everybody.
Thank you. Thank you very much. Thank you, Thomas.